Hello, welcome everyone, and thank you to the conference organizers for having me here today. I'm here also on behalf of my co-authors Diederik, Pomstra and Annelou van Gijn, and today we'll present on the importance of recycling of flint axes in the Vlaardingen Culture period based on a series of experiments that we have conducted. The experiments I'm presenting today have been conducted as part of the Putting Life into Late Neolithic Houses project. So today we'll start this presentation by introducing you to the project. After that I will introduce the archaeological background for this study, so that's the Vlaardingen Culture period. Next I will present the research questions for this study. And after that I will discuss the setup for the experiments. Then I will present the results of the experiments. And finally I will discuss the archaeological implications of our study. In 2016, Leiden University, together with volunteers from the Archaeological Open Air Museum Massa Muda, reconstructed a Neolithic Vlaardingen culture house using only Stone Age technology. Now, this house building project provided a lot of new insights, but it also raised a lot of new questions, because after this project we were actually left with an empty house. We still knew very little about how such a house would have been furnished, or how people would have lived in these houses. Therefore, this building project became the incentive for a new research project, and that's the Putting Life into Late Neolithic Houses project. And through experimental archaeology and detailed material analysis, we now try to gain new insights into the daily life in the Vlaardingen culture period. Now, in this project, we also collaborate with the volunteers of Massa Muda, who are involved in many of our experiments. So in the bottom left, you see, for example, the dugout experiment, in which we replicated a dugout with Stone Age tools. I thought it would also be nice if I would briefly introduce myself and also my co-authors. So first of all, Annelou van Gijn, she's the PI of the project. She's also my supervisor for my PhD research, and she's a microware specialist. And within this project, she analyzed the bone and antler tools. Now, Diederik Pomstra is an experienced craftsperson, and in this project he makes most of the replicated tools that we use. And he also supervises the experimental workshops with the volunteers in Massa Muda. Now, about myself, I'm a PhD candidate within the project, and my research focuses on object biographies of Vlaardingen culture Flint. So I look at the provenance of Flint, I study technology, I do use-wear analysis, but I also look at the recycling of objects, and that's the part I will be presenting on today. The Putting Life into Late Neolithic Houses project is an NWO project with multiple partners. So that's what you can see here on the slide. So we work together with different universities, notably Leiden University and the University of York. We work with archaeological companies such as BIAX, with governmental institutions such as the Dutch Cultural Heritage Agency, and also with artists like Kelvin Wilson. And XR is actually also one of our project partners, and they help us disseminating our research. So now I want to introduce you to the Vlaardingen culture. Now, the Vlaardingen culture is a Neolithic culture in the Western Netherlands. And their subsistence economy is characterized as a broad spectrum economy. So that means that in addition to crop cultivation and animal husbandry, they also heavily rely on the exploitation of wild resources. So we see that hunting, fishing and gathering also form important subsistence strategies in this period. In terms of lithic technology, it can be noted that the Vlaardingen period is characterized by a simple ad hoc flaking technology. And this is supplemented with the import of mined flint, notably of flint axes, such as the ones you can see here in the picture. These axes, they come from flint mining areas in Belgium and Limburg. It's important to note that flint is not locally available in the Western Netherlands. The closest known flint sources are located about 70 kilometers from these Vlaardingen culture sites. And we often see that flint was imported from even further away, notably from these flint mines such as Spien and Rijkholt, and these are located about 300 kilometers from these Vlaardingen culture sites. And because people had limited access to raw materials, we see that recycling played an important role in the technological system of the Vlaardingen culture. Especially flint axes were frequently recycled. And it's been estimated up to 10 or even 20% of the flint on some of these Vlaardingen culture sites consists of recycled flint axes. So these axe fragments formed an important contribution to the lithic assemblages on these Vlaardingen culture sites. Axes were flaked, and these flakes were turned into a wide variety of tool types, such as scrapers, borers, strikelites, and also ad hoc sickles, as you can see in the drawing on the right. It's important to note that these X fragments and the tools made from these X fragments can be recognized because they have a remnant of the outer polished surface of these X's. This outer surface can be seen as a kind of artificially created cortex. So here in the photographs you see a flake core and a scraper borer combination tool, which both have such a polished facet. And this is something that made me wonder, because this polished facet is only present when we are dealing with the outside of the X. This is similar to cortex, which is only present when you're dealing with the outside of a flint nodule. Now you can imagine that it's also possible to strike off flakes from the inside of the X. If you take the flake core in the center here, if you strike a flake off from the front, removing the polished facet that you can still see now, you will be left with a flake core which doesn't have a polished surface anymore. If you would then continue to strike flakes from this flake core, those flakes will also not have a polished surface. That means that those flakes could not have been recognized as polished X's or X fragments. Now, this is something I wanted to explore further, and that's why I set up an experiment to test out to what extent the archaeological assemblies also consist of archaeologically invisible X fragments, so X fragments which do not have this polished outer surface. Now, for these experiments, Diederik Pomstra replicated 4 oval flint axes. Now, 3 of these were specifically made for the experiment, and 1 axe was later added. This is an axe that actually broke during the dugout experiment with the volunteers of Massa Muda. And this provided a highly realistic addition to the experiment, because we actually expected most of these recycled axes broke during use before being recycled. Now, for the experimental axes, we based the dimensions on known archaeological axes. Those are Buren axes as they were reported by Bakker. So that's what you can see here in the bar charts. Now, we decided to focus on slightly smaller examples because we expect that most of these recycled axes would have been heavily resharpened and reshaped prior to being recycled. And 2 of the axes were broken deliberately in halves to replicate an end shock fracture. So that's what you can see here in the picture on the left. Now, these fractures are also observed on archaeological axes, and they occur when axes break during use. So this seemed to provide a realistic starting point for our experiment. Now, 1 of the axes was kept whole prior to flaking, and the 4th axe is the one that broke during the dugout experiment in Massa Muda. And the fragments resulting from that break were used in the experiment. Now, the flaking experiments were conducted by Diederik Pomstra as part of a public demonstration in Massa Muda. And this is what you can see here in the picture on the right. The axes were flaked to produce a variety of flakes which could have been used as blanks for tools. And for these flakes we documented whether these fragments had the remnant of the outer polished surface of the axe. So in the drawing you see 2 examples of axe fragments which still had this outer polished surface. In this table the results of the experiments are presented, and the results were highly surprising because it turned out that the majority of X fragments did not have a remnant of this outer polished surface. So this means that 59% of these X fragments could not have been recognized as X fragments, even though we know that in this experimental setting they all derive from recycled flint axes. Now, this was highly surprising because it means that we've greatly underestimated the importance of recycling of flint axes in the Vlaardingen culture period. Because the number of X fragments which is always reported for these sites actually only represents 41%, because those are the 41% of X fragments which you can still recognize based on this outer polished surface. So the majority of X fragments cannot be recognized as being part of X's. Our student assistant Tatjana Krombein also analyzed the microdebitage from these experiments. And this demonstrated that the invisibility of X fragments actually increases with fragmentation. So for the 4 to 10 millimeter fraction, only 23% of the X fragments still had a remnant of the outer polished surface. And for the smallest fraction, so the 1 to 4 millimeter fraction, this was only 21%. And these experiments have significant implications for our understanding of the archaeological record. X fragments with a remnant of the polished outer surface of the X only represent an estimated 41% of the total number of X fragments at a site. So simply put, If you have a site with 100 flint artifacts, and if 41 of these have a remnant of the outer polished surface of the axe, it seems plausible that your entire lithic assemblage derives from flint axes, even though you can only recognize 41 of these lithic tools as axe fragments based on the polished surface. Now, based on these experiments, we can now provide a more realistic estimate for the contribution of recycled flint axes in lithic assemblages. And in the table, we now estimate that for several Vlaardingen culture sites, how much of these lithic assemblages derived from recycled flint axes. Hereby, we account for the fact that axe fragments with a polished outer surface only represent 41% of the total number of axe fragments. Now, based on these calculations, we see that recycling was very important to some of these Vlaardingen culture sites. Sometimes up to 20 or even 40% of the lithic assemblages, as is the case with Hekelingen 3, consisted of recycled flint axes. That's much more than we previously assumed. And these results can also be used to interpret in what state flint was important to Vlaardingen culture sites. And in this table, this is something I've done for Hesbaye flint, so that's the most common flint type for flint axes in the Vlaardingen period. Again, we assume that the number of axe fragments with a polished outer surface only represents 41% of the total number of axe fragments. Now, based on these estimations, we see that on all of these sites, Hesbaye flint was predominantly imported in the form of flint axes, rather than as nodules. And this notion is also further corroborated by the fact that cortex is rather scarce on Hesbaye flint at these sites. To conclude, the importance of recycling on Vlaardingen culture sites has been greatly underestimated. About 59% of the axe fragments are archaeologically invisible because they lack this remnant of the outer polished surface of the axes. And this invisibility of axe fragments increases with fragmentation, and that's something that was clearly shown by the study of the microdebitage. Now, the experiments now allow us to better assess the importance of recycled flint axes on archaeological sites. And on some Vlaardingen culture sites, up to 20 or even 40% of the assemblages consisted of recycled flint axes. And lastly, we can also observe that some flint types, notably Hesbaye flint, were predominantly imported in the form of flint axes, rather than as flint nodules. Now, finally, I want to point out that this study has been published open access in lithic technology. So if you're interested, you can read more about it in detail in the original publication. Now, this study also led to this beautiful visualization, which is made by Kelvin Wilson. And here you can see someone recycling a broken flint axe. Now, it's also nice to note that the study was picked up by a Dutch newspaper, by the NRC. And finally, I want to point out that when you are dealing with recycled axes on your archaeological sites, that you need to be aware of these invisible fragments, because the majority of axe fragments will be archaeologically invisible when you are dealing with recycled flint axes. So this is what I wanted to close off with. I want to thank my co-authors, Diederik, Pomstra and Annelou van Gijn. And I also would like to thank the volunteers of Massa Muda and the students who contributed to this project. Well, thank you for listening, and please let me know if you have any questions about this.